Hello friend, welcome to my channel. Today I am discuss about valence bond theory, basic introductions of this valence bond theory, and then I will go the molecular orbital theory. So what is the valence bond theory and how what is the uh, when this theory have been developed. So this theory is developed by the due to the quantum mechanical theory, and they developed about the scientists who have developed about the bondings with overlapping of two orbitals. So in this theory, mostly they have considered the means and interaction between the atomic orbitals. uh, so in separate atomic atoms, they are brought bring together to form the molecules. So that means the interaction of two atomic orbitals, when they bring two together, they form the molecules. So this is the basic things of valence bond theory. And now I will discuss the basic thing how the form the orbitals means of a by a singles electrons of wave function. For example, if we treat hydrogen molecule for this valence bond theory. So so let's say electrons have wave function of this psi 1, wave function psi 1. I am going to explains how the orbitals will form, and second is electrons of hydrogen molecules, hydrogen atoms psi 2, and then it form the uh, psi 1 and psi 2, means superimposed. After superimposed, they form this psi 1 and psi 2. Psi 1 psi 2. So after superimposition, this is for first electron, this is for second electrons, comes from second electron. So psi 1 and psi 2 is the wave function. Psi 1 and psi 2 is the wave function. This is for H1. Let's say given names is S1, and this is S2 for second hydrogen molecule is S1, because in both having single electron. So how they form the orbital by mixing of two atoms. So let's say this is the total psi function of by mixing of the two means orbitals. Chi is for first atom hydrogen atom into chi 2b for second hydrogen second electrons, where chi 1 and where chi a chi b is the orbitals of the respective atoms, means first and second. This is equation first. And now now how to but the where the chi is denoted the atomic orbital. Mainly discuss this chi in computational chemistry. But one things I will tell you here, the some doubts, because the if we when the atom close to each other, whether it is electron one electron for this hydrogen atom and two electron, so either it form also in this way, psi is equal to chi a for second electrons, means second hydrogen of electrons, and chi b for first. So this way also we can write. So this is the, but both ways 1 and 2 are the possibility. So the outcome is in both cases equally uh, both from both equation. So according to quantum mechanics, what equation will become, we can draw the state function of these systems as a superpositions of the wave function, uh, like psi is equal to means combine of both equation, psi b psi 2 plus chi a, means chi a for second electron, chi b for one electrons. So this is the means superposition of this wavelength of each possibility. So so what this equation tells is, this equation tells how the means orbital will form as a form of what wave functions. So here the let's say for hydrogen atoms, this orbital for was and this orbital for second hydrogen atom, and they overlap between this single electron, and these are the nucleus. This is also nucleus. So an unnormalized wave function for hydrogen atoms, only paired electron can contribute to bond the valence bond. What does means single electrons only contribute to form the valence bonds, to form bonds. So therefore the wave function is formed by the spin pairing, means we can say the spin pairing, one is clock, one another is anti-clock, then it will form the bonds. So let's say we can how to form sigma bond. I will discuss how to form sigma by this orbital overlapping, SS orbital overlapping is formed the like this overlapping is formed sigma bond. Sigma bond. And also another way by overlapping of p orbitals, this sharing of these electrons here is also form the sigma bond. And side overlapping of p orbitals like this is form the pi bonds. This is the way to how to form the bonds by overlapping of the orbitals. So and now I will discuss the molecular potential energy versus curve of these hydrogen molecules. So how the variation of energy of molecule with internuclear separation, and it's calculated by the changing the internuclear separation R, and calculate the energy at the each selected separation. So let's say discuss for hydrogen molecule this. So what is the separation energy of this hydrogen like this? So this is the peak points for hydrogen. See, form covalent bonds, and here the means what repulsion is what increases due to the Coulombic electrostatic force, and that's why the energy again goes to increases. So and this axis is the internuclear distance dA, and this is the energy, this is the energy. So here this both atom is ground state in this air peak point, because the interaction is not more, that's why the energy is very low. So that's why this is the way to draw how to the molecular potential energy versus this internuclear distance. So here we can also see here like this, like this is the, let's say this one nucleus 1, this is nucleus 2. They will, when they will repel to each other, and the energy will increase, and the energy will goes up. So this is the things of how the potential energy of these molecules depends with internuclear distance. So now I will discuss about the molecular orbital theory. What is the molecular orbital? What is the need of this molecular orbital theory? What is the need of this molecular? Because the valence bond theory, earlier valence bond theory have only given limited source about the bonding in simple molecule, and also they did not tell about the bond order and magnetic properties, all those things. That's why here we needed the molecular orbital theory, and this theory is very helpful and give the good results also about all introduction of the all molecules. So and it does not applicable for polyatomic molecules, and that's why the molecular orbital give the more advanced model for bonding that can equally to that can applied equally to simple and complex molecule. But this theory tells energy things about the bond order and magnetic properties. So so what is the approximation? The molecular orbitals are made linear combination of the atomic orbitals. That means the the means molecular orbital form with linear combination of atomic orbitals. This is the main points, because it could be high probability to finding electrons in atomic orbitals that have large coefficient in the linear combinations. Each molecular orbital can occupied by up to 2 electrons. By up to means maximum 2 electrons, and in most elementary form the molecular orbital, the valence shell atomic orbitals are used from the molecular orbitals. So now I will discuss the what is the basic things of bondings and antibondings. The basic thing, bondings and antibondings. So bonding orbitals comes from the constructive interference of neighboring atomic orbitals, but antibonding orbital comes from the destructive interference, indicate the nodes between the atoms. Let's if I try to how to the form the bonding and antibonding. Let's this this is for, let's say, to hydrogen orbital, how to contractive interference form the bonding like this. When they then contract, its intensity goes high. and by constructive interference and here no nodes, but for anti-bonding one node will come. So here these nodes, so here the zero possibility of electron density. So this is the antinodes comes due to the destructive interference. So this is the basic things, bonding and antibonding. So now I'm going to draw the molecular orbital energy level diagrams for only the hydrogen molecules. So as we earlier told you, it's from the means what I can say means linear combination of atomic orbitals, so of same energy. So if I try this like this, for hydrogen case the orbitals of this H1, HA and HB atoms should be same, and this is anti and this is bonding. So as you know, hydrogen molecule form by sharing of 2 electrons, and one hydrogen atoms has only single electron. So this is the bondings, and this is anti-bonding. This is psi 1. If we denote psi 1, this is psi plus, and this is bonding. And what is the band gap of this? Approximately 11.5 electron volt. So this is the energy MOT. MO means molecular orbital energy diagram of hydrogen molecules. So here also we can say the in homonucleus molecular orbital HA and HB bond energy would be same. As I told, this energy should be always same for means homo molecular orbitals. Homomolecular orbitals energy should be same. Energy should be same. So please guys think please be thinks this thing, but this energy level is not same for hetero diatomic molecules. This is the main difference between hetero and homo. So why now I will go why the energy of the bonding orbital is lower than the anti-bonding orbitals. So I will try what is the reasons why the bondings orbital goes energy is lower and anti-bonding energy is higher. So in bonding orbitals, the more probability to found electrons the internuclear regions, because they can interact strongly with the nucleus. That's why the energy is lower. Therefore the energy is lower. But in case of antibonding orbitals, the symmetry, the means asymmetry arises partially from the electron distribution and partially from the fact that the internuclear repulsion pushes the entire energy to higher level. So as that means what is the conclusion? What is the conclusion for the bonding? uh, the probability of electron found the internuclear region because the interaction strongly between the nucleus, that's why the energy goes lower. But in case of antibonding, the if you see here, in case of antibonding, the asymmetric arises partially from the electron distribution, partially from the fact that internuclear repulsion, that's why energy goes up. So this is the reason why the energy goes up for antibonding, why the energy goes down the bonding. So so now, as I told you, as I explained earlier, how to form sigma bond, pi bond by overlapping of s orbital and p orbital, and s and p orbitals, and ss means pp orbital and side by side orbitals. You people knows about how to form. I will not go discuss about this sigma, pi and delta orbitals. So now I'm going to the most important things. One point I will tell you, because this is also most important. If you go the electronic means configuration, molecular orbital configuration of this, then you need to the G rate and energy rate. Spectrosymmetric spaces such as G rate are G rate according to their symmetry with respect to inversion. So and one thing here I will tell you, the sigma means 1s orbitals, and this pz overlapping form the sigma bond. By this overlapping form the sigma bond. Why the pz is only the rules for this formation of, not px, py? Because people are from initially are considering that this pz only the rules for the sigma bonds, not px and py. And I think these things I will also use for the means electronic configuration, means orbital electronic configuration for homo molecules. So this is important things which you have to always keep in your mind, this formula. So if you consider the homonuclear diatomic molecules like H2, F2, H2 electrode and O2, B2. So this is the nuclear diatomic molecules. And if first case first, if the electrons, total valence electrons of this molecules is more than 14, then what will be the configuration, means how to fill the electron in orbital form. So sigma 1s, here we also use the species of G-rate and G-rate. G-rate for bonding G-rate, and sigma star 1s and G-rate antibonding, and it's like that. Sigma 2s for G-rate and sigma star 2s and G-rate. Sigma here not px py is coming, here is coming sigma 2 p z G-rate and pi 2 px, and these two orbitals have equal energy, so pi p 2 py and G-rate, and pi star antibonding 2 px and is equal to pi star 2 py and G-rate and sigma star 2 pz and G-rate. So as you know, as told you what is G-rate and G-rate, the G-rate only designed for the event if it is in identical under inversion, then we can say it's G-rates. What in case if you see in this way, in symmetry, if you learn symmetry, what I can say here, if we draw like this, then if this line is going from main axis from center, and here are going, and this side also going, and if you same distance going same thing, then it is center inversions. And if we go this side, if we get here minus, here get plus, so this is on for un-G-rates. So this if you go minus to plus, both the side is not coming same, so we can say un-G-rate. And if you go both side is coming same, so plus to plus, you can say G-rate, sigma G-rate. That means the same things appear when go both side, then you can say G-rate, otherwise un-G-rate. So understood. So this is the basic things where we are using G-rate and where we are using un-G-rates. Okay guys, so so another formula is, if I write another formula, what is the another formula? What is the another formula? If the electrons means what I can say, if the electrons greater than, earlier I told you for greater than electrons, and this time if the electron total valence electrons of the molecule is less than or equal to 40, then what will be, only basic term will change. What will change? See, first will for sigma case is everything same, sigma 1s, and in this term sigma 1s G-rate, sigma star 1s and G-rate, and sigma 2s G-rate, sigma 2s and G-rate, So here guys, you see here only the change first come with pi orbitals. So for uh, less than uh, 14 are equal to 14 electron, so 2p y is equal to pi 2p, not 2px, not y, and 2p y, and sigma. This is the for the sigma 2p z, and pi 2px is equal to pi 2py star for antibonding, and sigma star 2pz. So this is for the less than or equal to what 14 electrons. So here is ungirate, here is the what incandescent ungirate, here is girate. So here is girate, here is ungirate. Okay guys, so this is the things, and you people now fill the electron in this, and you can calculate the also by the help of this filling of electrons, you can calculate the bond order also. So first one example I will tell you for less than or equal to 14 electron. Let's say example of this nitrogen molecule. So its electrons, total valence electron is what, not valence, total electrons is having 14, not sorry valence electron, total electron. Nitrogen has valence electron 5, but total say 7 electrons, so 7 7 14. So if you see this electron is following the rules of this formula, less than or equal to 14 electron, so we apply this formula. So if we fill this, then as you know the sigma 1s 14 electrons, sigma 1s to 0, sigma star 1s to ungirate, sigma 2s to 0, sigma star 2s to ungirate, and pi square pi 2p x is equal to pi square 2p y, and sigma you count total electron how much, 2 4 8 and 10 and 14. So I have filled more, how much, 2 4 4 4 8 8 12, yeah right, 14. So so here we can also calculate the bond order. So what is the bond order? So bond order is simply 1 divided by 2 bonding minus antibonding, antibonding, right, antibonding, not bonding and antibonding. So if you see bonding, how much bonding are electrons, this is 2 4, and what is this, 4 2 4 and 4 8 and 2, how much, 10. This is 10 bonding and anti-bonding 4. So divided by how much, 6, but divided by 2 is 3. As you know, 3 is the bond order of this nitrogen. This 3 is the bond order. So from with the help of this we can calculate the bond order also. Now I am giving one examples of more than uh, 14 electrons. If you take this hydrogen or oxygen molecules, so total electron is so large, so it is the more than 14 electrons. So I will apply not this formula, we apply this formula. See, more than 14 electrons. So what will be the filling of electrons here? You see, so sigma 1s 2 zeroth sigma. So here no need of zeroths, but you should if you repeat repeatedly, then you can will learn how where is will be the zeroth, where will be the unzeroth. Sigma star 2s2 unzeroth, and sigma 2p square z zeroth, and pi 2px, okay, pi square 2px बराबर pi 2p square by unzeroth. And this is for antibonding. Pi 2px is equal to pi. Here if you see how much electron I filled, 2 4 6 8 8 8 8 8 8 8 8 and 8 and here say 8 10 10 10 to 12 14, and here we fill single electron, then will become 16. So pi 2p x 1 electron is equal to, because both energy level following the filling the single electron, 2p 2py is equal to 2py is 1. So this is the, if you count here 2 4 6 8 10 and 14, 2 to 14 to 16. So what is the bond order? If you calculate bond order, so bond order 1/2 bonding orbitals, electrons means minus antibonding electrons. So what is the bonding? This is bonding 2 4 and 6 6 6 6, and this 4 10 10 is bonding, minus 6 is antibonding by 2 divided by 2, and this become 4 by 2. So and this is bond order 2. So if you see oxygen molecule has bond order like this. Oxygen is one oxygen bonded, means double bonded with another oxygen. So this is the bond order. So I thought you guys learn what is the bond order and what is the how to means calculate the how to fill the electrons through the MOT theories. So thank you guys, but people are also we can also think about little bit. I will give some idea about heteroatoms. Hetero means heteronuclear, because earlier I told you homo means diatomic, homonuclear diatomic. Now here I am telling you heterodiatomic molecules. So in this molecule the orbital having unequal energy. So unequal energy means the both contribution of each atom orbital will not equals. So here the basic point is unequal contribution of atomic orbitals, and the molecular or polar bonding electrons found to be more electronegative atom, and anti-bonding electrons are less electronegative atoms. So here the example HF, like this is hetero, and CO, ICLs, this is the hetero atoms of high energy hetero. And if I try to draw the energy level of these, let's consider the here the energy level diagram should be like this. So let's say for HF molecules higher energy. So for HA, chi of HA orbitals is here, and HB, this should be not be equal, HB should be here. So this will be the orbital overlapping, this will be the orbital overlapping. So so here the this one is the more electronegative rather than hydrogen atom. That's why the both energy is not equals. So here we can also draw the like this. So this is for bonding orbital, this is for anti-bonding orbital. So this is the basic things. So guys, thank you for your patience. So please subscribe my channels and like also. Thank you.